Okay, today we are going to factor a quadratic where a equals 1. It's also called factoring trinomials. So just to review real quick, when you're given, let's say, two binomials, right, and then we would multiply, you either use the FOIL or maybe call it over, under to simplify this, and we would go over x squared minus 4x minus 2x plus 8, and then you'd combine like terms. So just kind of review that real quick. You know, this, when we would multiply this out, simplify it, we would get this trinomial here. Well, if you look at our first example, we are starting backwards. We're looking at the trinomial, and we want to get back to what two binomials were we multiplying to get this trinomial. So here we go. What first thing we need to do is identify our a, b, and c. So going back to that standard form, ax squared plus bx plus c. You'll notice our a is 1. It will be 1 on all of these. Okay. So here a equals 1, that leading coefficient. B is our second coefficient, which is a positive 9, and c is our constant at the end, which is 18. So the first step, identify a, b, and c. Okay. Now, in math, sometimes the most difficult part is, okay, where do I start? And then the second is, what is my answer supposed to look like? Like, when am I done with this, right? So I'm telling you right now, your answer is going to look like this. Two sets of parentheses, and we are going to find those two missing numbers here in our binomial, right? And to do so, I'm going to use a table to kind of help organize my thoughts here. What we're going to do is kind of solve a puzzle here. I want to know what are the factors of the product of a times c, and that give me a sum when I combine those together of b. So a and c are 1 and 18. So 1 times 18 is 18. So I'm looking at factors of 18. Factors are 1 and 18, 2 and 9, 3 and 6. Okay, and then it's kind of like a puzzle. Okay, we're just going to go through. I know all my factors of 18. Now, if I combine those, what is going to give me a sum of 9? A sum of 9. Well, 1 plus 18 is 19, so it's not that one. 2 plus 9 is 11, so it's not that one. And 3 plus 6 is 9. So we have solved our puzzle. So what that is telling me is a positive 3 and a positive 6 are my answers. Okay. Looking at our example 2, you'll notice that our leading coefficient is still 1. So a is 1. B is negative 9. Don't forget to take the sign in front. And our c is a positive 8. Okay. Remembering our answer is two binomials being multiplied together using our variable x. I say that because sometimes we like to sneak in a different variable and makes us think that we solve the problems differently, but we don't. It's the same process over and over again. All right, using my table, I'm going to keep track here. Again, I'm looking for the products of a times c, which is 1 times 8, which is 8, and that give me a sum of b, which is negative 9. Be careful, they are changing our signs on us a little bit. So I'm going to go ahead and list my factors of 8, 1 and 8, 2 and 4. Oh no, I wrote my problem down wrong. That's a silly mistake. We're going to do 18 again, and you're going to see why in just a minute. So that's an easy fix. 1 and 18, 1 times 18 is 18, 2 and 9, 3 and 6. And the reason we're doing this example is it's similar to example 1, but I want you to see what happens when we sneak a negative in there. Okay. So again, fix that. It's supposed to be 18. write the problem down right. And I need a sum of 9. So I really need to think of my integer rules here. If I'm adding two numbers, which one needs to be a negative for my answer to be a negative? Okay, and that's going to be the larger number. Okay, so a larger number, oh, but look, my product needs to be a positive 18. So if we remember our integer rules for multiplying, a negative times a positive is a negative, and a negative times a negative is a positive. So that tells me both of these need to be a negative. And then I can just check which one fits this rule of, okay, now when I combine them, I get a negative 9. Obviously, it's not the first one. That would be negative 19, negative 11. There's my negative 9. So that tells me this is a negative 3 and a negative 6 in my answer. Okay, on our example 3, you'll notice that our x's have changed to b's. That's perfectly fine. All that means is in my answer, I will have b's instead of x's. The process has not changed, and I know sometimes we think that if it looks a little bit different, they're changing something on us. They are not. It's still in that x squared plus bx plus c form. Okay, so don't stress. A still equals 1. It's important for us to notice that because it does change when A isn't 1. There's some different steps we have to do. B is a positive 4, keeping the signs in front, and C is a negative 12. Come over here to my table. My table just helps me organize all my thoughts. A times C and a sum of B. So A times C is negative 12 and a sum of a positive 4. So I'm going to go ahead and list my factors of 12, 1 and 12, 2 times 6, 3 times 4. Okay, and just reviewing my integer rules again, a negative times a positive is a negative, and a negative times a negative is a positive. So that tells me if I need it to be a negative, one of those numbers is going to be positive and one is negative. And then I have to also think about, I have to get a positive answer. So if one of them has to be a negative, but my sum, when I combine them, I get a positive, that means the smaller number should be the negative. So I'm going to go ahead and put the negatives in there, and then let's test it. So negative 1 plus 12 is 11, not it. Negative 2 plus 6, 4. Cha-ching, there it is. And so we get negative 2, positive 6. And if you wanted to, you could go ahead and test the last one. If you have some trust issues there, and you'll notice negative 2 and 6 is our answer. Alrighty, our last example for this lesson, and this one's a little bit trickier, but let's go ahead and get started. You'll notice our x's are still b's, or our b's now, but still in ax squared plus bx plus c form, so don't get upset and think that I'm giving you something different. It is the same process, just different variables. Alright, so a is still 1, b is a negative 1, and c is a negative 90. See, they're a little bit more challenging here. That's okay. So a times c is 1 times negative 90, which is negative 90. And my b is a negative 1. So my factors of 90, 1 and 90, and I see I need a difference of 1. So eventually you'll get confident enough that you won't be listing all of your factors. 2 and 45, 3 and 30. See, I know these are not going to get me anywhere close. 5 and 18, and I'm just dividing 90 by 5, 90 by 6. And the divisibility rule of 6, if 2 and 3 work, 6 works, so I need to divide it by 6. Divide by 7, I get a decimal. Divide by 8, I get a decimal, and then there's 9 and 10. So again, the more confident you are with your multiplication facts, the quicker this will be for you, but you have a calculator, you can test those numbers. I know that there's a difference of 89 here, so I'm going to go down to 9 and 10 because I know there's a difference of 1, and then I just have to figure out my signs. So again, I know for me to get a positive when I'm multiplying, that's a negative times a positive is a negative. So one of these has to be a negative, and then if I combine them, I also should get a negative. Okay, and if you're not sure, just test it. Negative 9 plus 10 is 1, and 9 plus a negative 10 is negative 1. So you can always go off to the side and test those or plug them into your calculator to check it, but as we see, our 10 needs to be the negative. That gives me my negative 1. Therefore, my two terms are a positive 9 and a negative 10. And that's it. So we're going to be practicing a lot with our integer rules and our factors.